Oh yeah, thank you, Saji. Yeah, we have the three stages. The first, yeah, you have not the same order, but it doesn't matter. Release testing, development testing, and user testing. Normally, they have a order. We have at first the development testing. As development testing during this period, yeah. Oh. During the development testing, it's the system designers and programmers who are likely to be involved in the process. And for the release testing, we'll check that the system meets the requirements of system stakeholders. It is a complete version of the system before it is released to users. Then the last one is the user testing. Yeah. In this stage, users or potential users of a system will test the system in their own environment. So it is just before the delivery. These are three stages of testing. And later, we have talked about the development testing. Yeah, we have talked about these three stages in detail. The first one is the development testing. For development testing, we have talked about the three levels of granularity. Do you remember three levels of granularity during development? Yeah, thank you, Saddam. What you call it always object class testing? I think the last time you have talked about something like this too. Also, yeah, like said by Kaya, component testing, system testing. Yeah. Thank you, Saddam, Kaya, and Saji. Yeah, these are three levels of granularity carried by the testing during development. We have the unit testing, which focus on testing the functionality of objects or methods. Then we have the component testing. We focus on testing component interfaces. And the system testing, we focus on testing component interactions. It's like a pyramid. Yeah, from unit to the integral. And then, yeah, we have detailed the three levels of granularity. For the unit testing, we have talked about automated test, and we say that automated test have three. Yeah, an automated test had three parts. Do you remember the three parts of automated test? Which one? Oh, yeah, thank you, Sakaya. But Saddam, what's your question? I didn't understand your question. Which one? For the three parts of an automated test, it's like what said by Kaya. A setup part will reinitialize the system with the test case, the inputs and the expected outputs. A core part will record the objects or method to be tested. And then on the assertion part, to compare the result of the core with the expected result. Yeah, and then we have talked about how to choose unit test case. Later we have specialized. The component testing. For the component testing, we have talked about 4 types of interface error. Yeah. Do you remember the 4 types of interface error? Yeah, thank you, Saddam. Parameter interfaces, shared memory interfaces, procedure interfaces, and message passing interfaces. Yeah, exactly. Thank you, Saddam. And another similar question is 3 classes of interface errors. Interface misuse. Yeah. Thank you, Atman. Interface misuse, interface misunderstanding, and time errors. And thank you, Saddam, too. Yeah, these are 3 classes of interface errors. So don't mistake these 2 classifications. One is 3 and another is 4. And yeah, here we have also talked about the stress testing. Don't forget the notion of stress testing. And later, we have passed the test-driven development. We have talked about the benefits of test-driven development. Yeah, here we have listed 4 benefits of test-driven development. For test, oh, I'm sorry. Yeah, 4 benefits for benefits of test-driven development. Yeah, code coverage, regression testing. Yeah, simplified debugging, and system documentation. Yeah, thank you, Kaya and Asma. Yeah, excellent answers. We have these benefits of test-driven development. And later, we have talked about the release testing. For the release testing, we have talked about the scenario testing and the performance testing. After release testing, we have talked about the user testing. For user testing, we have specialized 3 types of user testing. Do you remember which 3? Yeah, thank you, Saddam. Alpha testing, beta testing, and acceptance testing. These 3, and as Asman also, thank you. These 3 types of user testing, and we talked about the 6 stages in the acceptance testing process. Define acceptance criteria, plan acceptance testing, derive acceptance tests, run acceptance tests, negotiate test results, and reject or accept system. Yeah, these are some points for the 8th chapter, software testing. Now we are going to the 9th chapter, which is about the software evolution. The objective of this chapter are to explain why software evolution is an important part of software engineering and to describe software evolution processes. When we have read this chapter, we will understand that change is inevitable if software systems are to remain useful, and that software development and evolution may be integrated in a spiral model. Also, we need to understand that software evolution processes and influences on these processes. We need also to learn about different types of software maintenance and the factors that affect the maintenance costs. For the software evolution, we have also to understand how legacy systems can be assessed to decide where they should be scrapped, maintained, and re-engineered or replaced. More precisely, in this chapter, we will cover these topics. The evolution processes, as we say, change processes for software systems to keep it always useful. Programming evolution dynamics to understand the software evolution, software maintenance to make changes to operational software systems, and legacy system management to make decisions about software change. Okay, these are the topics covered in this chapter. And software development does not stop when a system is delivered, but continues throughout the lifetime of the system. After a system has been deployed, it inevitably has to change if it is to remain useful. We have different reasons why the software change is inevitable. You see, we may have new requirements emerge when the software is used. Before using, perhaps we don't realize some special requirements, but after using, we know exactly what we know concise what we want, and we may emerge new requirements. Also, the business environment changes. Nowadays, the environment change rapidly, not just the natural environment, but also some business environment too. Also, we need to repair some errors, for example, debugging or some other functional errors. In some cases, we may have new computers or new equipment added to the system. Then we need to change the software to be adapted to the change. Also, we may have the situation that the performance or reliability of the system may have to be improved. Yeah, you see, the requirements may change, the users may change, the demands may change, so we cannot avoid the software changing. And the key problem for all organizations is implementing and managing change to their existing software systems. Yeah, as we say, business changes and changes to user expectations generate new requirements for the existing software. Part of the software may have to be modified to correct errors that are found in operation, to adapt it for changes to its hardware and software platform, and to improve its performance or other non-functional characteristics. As we have so many reasons that software change is important, as organizations have invested large amounts of money in their software and now completely dependent on these systems. Their systems are critical business assets and they have to invest in system change to maintain the value of these assets. Consequently, most large companies spend more on maintaining existing systems than on a new systems development. Yeah, here we have said it. Organizations have huge investments in their software systems. They are critical business assets. To maintain the value of these assets to the business, they must be changed and updated. Yeah, software evolution may be triggered by changing business requirements, by report of software defects, or by changes to other systems in software systems environment. And the majority of the software budget in large companies is devoted to changing and evolving existing software rather than developing new software. Yeah, therefore, the evolution of a system can rarely be considered in isolation, and changes to the environment lead to system change, and that may then trigger further environmental changes. Of course, the fact that systems have to evolve in our system's-rich environment often increases the difficulties and the cost of evolution, as well as understanding and analyzing an impact of a proposed change on the system itself. We may also have to assess how this may affect other systems in the operational environment. And useful software systems often have a very long lifetime. For example, large military or infrastructure systems such as air traffic control systems may have a lifetime of 30 years or more, and business systems are often more than 10 years old. Software costs a lot of money, so a company has to use a software system for many years to get a return on its investment. Obviously, the requirements of the installed systems change as the business and its environment change. Therefore, new releases of the systems incorporating changes and updates are usually created at regular intervals. Yeah, We should therefore think of engineering as a spiral process with requirements, design, and testing going on through the lifetime of the system. As this figure shows, we start by creating release 1 of the system. Once after delivering, changes are proposed and the development of release 2 starts almost immediately. And in fact, the need for evolution may become obvious even before the system is deployed, so that later releases of the software may be under development before the current version has been released. And this model of software evolution implies that a single organization is responsible for both the initial software development and the evolution of the software. Most packaged software products are developed using this approach, this spiral model of development and evolution. For custom software, a different approach is commonly used. A software company develops software for a customer, and the customer's own development staff then take over the system. They are responsible for software evolution. Alternatively, the software customer might issue a separate contract to a different company for system support and evolution. So you see, in this case, there are likely to be discontinuities in the spiral process. Requirements and design documents may not be passed from one company to another, and companies may merge or reorganize and inherit software from other companies, and then find that this has to be changed. When the transition from development to evolution is not seamless, the process of changing the software after delivery is often called software maintenance. In this chapter, when we talk about maintenance, it involves extra process activities such as programs, understanding, in addition to the normal activities of software development. And here we propose an alternative view of the software evolution life cycle. In this model, we distinguish between evolution and servicing. Evolution is the phase in which significant change to the software architecture and functionality. It's like shown in this figure. We distinguish between evolution and servicing. Evolution is the phase in which significant changes to the software architecture and functionality may be made. And during servicing, the only changes that are made are relatively small essential changes. So during evolution, the software is used successfully and there is a constant stream of proposed requirements changes. That's why here we say for the evolution, the stage in our software systems life cycle where it is in operational use and is evolving as new requirements are proposed and implemented in the system. For the servicing, at this stage, the software remains useful, but the only changes made are those required to keep it operational. Bug fixes and changes to reflect changes in the software's environment. New no new functionality is added. So you see we have big differences between evolution and servicing. Yeah, as shown, just as shown in this figure, during the evolution, this part, the software is used successfully and there is a constant stream of proposed requirements changes. However, as the software is modified, its structure tends to degrade and changes become more and more expensive. This often happens after a few years of use when other environmental changes, such as hardware and operating systems, are also often required. And at some stage in the life cycle, the software reaches a transition point where significant changes implementing new requirements become less and less cost-effective. Yeah, and then we have the third part. Yeah, as in this figure, we have the third stage, which is the phase out. After the evolution, we move from evolution to servicing, and during the servicing stage, the software is still useful and used, but only small tactical changes are made to it. And during this stage, the company is usually considering how the software can be replaced. Then in the final stage, we have the phase out. The software may still be used, but no further changes are being implemented. So users have to work around any problems that they discover. Yeah, this is the change. Yeah, the evolution and the servicing phases. Yeah, we'll have a break of 10 minutes if you want, and I'll note for your attendance. This is the software evolution life cycle. We have 4 activities: initial development, evolution, servicing, and phase out. Can you explain the evolution and the servicing processes? Please explain the evolution and the servicing activities. These 2 activities, how to explain them? Update and add features, yeah? And servicing, fixing errors, okay? Yeah, you have, Roy, thank you very much. You have given yeah, you have given a small and brief explanation of these 2 activities. Yeah, for the software evolution, during the evolution process, we can still use software successfully, and there is a constant stream of proposed requirements change. However, as the software is modified, its structure tends to degrade and changes become more and more expensive. This often happens after a few years of use when other environmental changes, such as hardware and operating systems, are also often required. At some stage in the life cycle, the software reaches a transition point where significant changes implementing new requires become less and less cost effective. Yeah, as you said, Roy, for the evolution process, we update and add features according to different changes of the environment. And later, the software moves from evolution to servicing. It's here. We move from this stage to this stage. And during this servicing phase, the software is still useful and used, but only small tactical changes are made to it. And during this stage, the company is usually considering how the software can be replaced, as you said, fixing errors. And in the final stage, it is the phase out. The software may still be used, but no further changes are being implemented. Users have to work around any problems that they discover. We'll go with the problems. We'll work with it. Yeah, here is the explanation of these activities. Now we'll pass to our next section, which is the evolution processes. We'll see it in detail. Software evolution processes vary depending on the type of software being maintained, the development processes used in our organization, and the skills and experience of the people involved. So you see, in some organizations, evolution may be an informal process where change requests mostly come from conversations between the system users and developers. In other companies, it is a formalized process with structured documentation produced at each stage in the process. And so proposals for change are the driver for system evolution. System change proposals are the driver for system evolution in all organizations. Yeah, if there is no system change proposal, normally we don't do the system evolution. And change proposals may come from existing requirements that have not been implemented in the released system. Requests for new requirements, bug reports from system stakeholders, and new ideas for software improvement from the system development team. And the processes of change identification and system evolution are cyclic and continue throughout the lifetime of a system. Here, change proposal should be linked with the components of the system that have to be modified to implement these proposals. This allows the cost and the impact of the change to be assessed. And this is a part of the general process of change management, which also should ensure that the correct versions of components are included in each system release. Here, yeah, you see, we can change identifications, and the evolution continues throughout the life the system lifetime. Here, this figure shows an overview of the evolution process. In this process, you see yeah, as we said, the processes of change identification and system evolution, they are cyclic and continue throughout the lifetime of our system. You see, we change identification process, we have the change proposals, and it is linked to the components of the system that have to be modified to implement these proposals. And this allows the cost and the impact of the change to be assessed. This is part of the general process of change management, and we should ensure that the correct versions of components are included in each system release. You see, it's a cycle. Change proposal, software evolution process, new system, change identification process, and change proposal. Also, this figure, it shows another view of the evolution process. In this process, we have the fundamental activities of change analysis, change requests, impact analysis. We have release planning, system implementation, like change implementation, system release, in which we release our system to customers. The cost and impact of these changes are assessed to see how much of the system is affected by the change and how much it might cost to implement the change. If the proposed changes are accepted, a new release of the system is planned. And during release planning, all proposed changes, fault repair, adaptation, or new functionality, they are all considered. And the decision, and we will make a decision on which changes to implement in the next version of the system. And the changes are implemented and validated. A new version of the system is released, and the process then interacts with a new set of changes proposed for the next release. Yeah, you see, with this process, the software evolution process, we can think of change implementation as an iteration of the development process where the revisions to the system are designed, implemented, and tested. However, a critical difference is that the first stage of change implementation may involve program understanding, especially if the original system developers are not responsible for change implementation. During this program understanding phase, we have to understand how the program is structured, how it delivers functionality, and how the proposed change might affect the program. And we need this understanding to make sure that the implemented change does not cause new problems when it is introduced into the existing system. And ideally, the change implementation, this stage of the process, should modify the system specification, design, and implementation to reflect the changes to the system. Like in this, here, this figure, you see the change implementation stage of the process should modify the system specification, design and implementation to reflect the changes to the system. And new requirements here that reflect the system changes to the system. We propose these new requirements that reflect the system change, and we will also analyze and validate the system changes, and system components are redesigned and implemented, and the system is tested. If appropriate, prototyping of the proposed changes may be carried out as part of the change analysis process. So during the evolution process, the requirements are analyzed in detail, and implications of the changes emerge that were not apparent in the earlier change analysis process. And this means that the proposed changes may be modified, and further customer discussions may be required before they are implemented. And change requests sometimes relate to system problems that have to be tackled urgently. And these urgent changes can arise for different reasons. We'll see the reasons later. Now we'll see the change implementation. As we have said before, iterations of the development process where the revisions to the system are designed, implemented, and tested. A critical difference is that the first stage of change implementation may involve program understanding, especially if the original system developers are not responsible for the change implementation. During the program understanding phase, we have to understand how the program is structured, how it delivers functionality, and how the proposed change might affect the program. This part is about the urgent change requests. We have said that urgent change may have to be implemented without going through all stages of the software engineering process. And we have 3 reasons for the urgent changes. The first one is if a serious system fault has to be repaired to allow normal operation to continue. The second reason is that if changes to the system's environment, for example, an operating system upgrade, have unexpected effects. And the third reason is that if there are unanticipated changes to the business running the system, such as the emergence of new competitors, new competing products, or the introduction of new legislation that affects the system. Like said here, if there are business changes that require a very rapid response, like the release of a competing product. So you see in these, in these situations, in these cases, the need to make the change quickly means that we may not be able to follow the formal change analysis process. So rather than modify the requirements and the design, we may make an emergency fix to the program to solve the immediate problem. And to solve it, it's like this. This is Yeah, this corresponds to an emergency fix. You see, comparing to the change implementation, here it was the proposed changes. Here we have change requests. Before, here was requirements analysis. Now we have analyzed source code. And we had requirements updating here. Now we have modified source code. Then software development is changed to deliver modified system. And before we had a flash, we had a return from the requirements analysis to propose the changes, and now it's linear like this. You see the difference between the emergency repair process and the change implementation. However, with this emergency repair process, the danger is that the requirements here, the software design and the code, they become inconsistent. Although we may intend to document the change in the requirements and design additional emergency fixes to the software may then be needed. These take priority over documentation. Eventually, the original change is forgotten and system documentation and code are never realigned. So you see, emergency system repairs usually have to be completed as quickly as possible. And we chose a quick and workable solution rather than the best solution as far as the system structure is concerned. And this accelerates the process of software aging so that further changes become progressively more difficult and maintenance costs increase. Normally, to be idle, when emergency code repairs are made, the change request should remain outstanding after the code faults have been fixed. It then can be implemented more carefully after further analysis. Of course, the code of the repair may be reused, and an alternative, better solution to the problem may be discovered when more time is available for analysis. And in practice, it is almost inevitable that these improvements will have a low priority, and they are often forgotten, and if further system changes are made, it then becomes unrealistic to redo the emergency repairs. In the third chapter, we have talked about the agile methods and processes. We may also use agile methods and evolutions for programs evolution and program development. In fact, because these methods are based on incremental development, making the transition from agile development to post-delivery evolution should be seamless. That means agile methods are based on incremental development, so the transition from development to evolution is a seamless one. And evolution is simply a continuation of the development process based on frequent system releases. We have different techniques like automated regression testing. They are useful when system changes are made. It is particularly valuable when changes are made to a system. And changes may be expressed as additional user stories. Also, we may use customer involvement can prioritize changes that are required in our operational system. So in short, evolution simply involves continuing the agile development process. However, problems may happen in situations in which there is a handover from a development team to a separate team responsible for evolution. We have two potentially problematic situations. The first one is where the development team have used an agile approach, but the evolution team is unfamiliar with agile approach, agile methods, and prefer a plan-based approach. In this way, the evolution team may expect detailed documentation to support evolution, and this is not produced in the this is rarely produced in agile processes. And there may be no definitive statement for the system requirements that may be modified as changes are made to the system. This is the first problem we may have for handovering from one development team to a separate team responsible for evolution. A second problem may evolve is that where a plan-based approach has been used for development, but the evolution team prefers to use agile methods. In this case, the evolution team may have to start from scratch developing automated tests, and the code in the system may not have been refactored and simplified as is expected in agile development. And in this case, some engineering may be required to improve the code before it can be used in agile development process. Some authors report on their experiences in using extreme programming for maintaining a large system that was originally developed using a plan-based approach. And after re-engineering the system to improve its structure, extreme programming was used very successfully in the maintenance process. Okay, this part is for the evolution process. Perhaps we'll continue for the program evolution dynamics next time. And now we'll have something to do with what is learned in this part. Okay. Okay, Roy, and Ramnak. Okay, I have noted, and I have seen your message. And now, please talk about. Okay, we have, we had perhaps a brief introduction of the change implementation process and the emergency repair process. So what can we do here? I'll leave this question as a assignment. I'll say you can. It's like this. Use please use diagrams and text to explain the change implementation process and the emergency repair process. Please use diagrams and text to explain the change implementation process and the emergency repair process. Emergency repair process is like fixing your tires which just got flat in the middle of a long drive. Yeah, a good example. Yeah, a very live example. Yeah. And you see here, in this chapter, we talk about software evolution. So we should focus on how we solve this problem. Roy, thank you very much. You have given a perfect example about the situation. You see here, we have faced a situation as an emergency repair process. Yeah, our situation where we need an emergency repair process. But what will we do in this process? We need, yeah, it's better to illustrate this part in more detail. Is it clear? This is something Xiaomi has been doing for a while now with their software. It is very annoying. Emergency repair process. Okay, yeah. You have bought some Xiaomi products like mobile phones or something else?